Good morning. Welcome back. Today's lesson is going to look at giving you the solutions to section 8.4. And just give me a second. There we go. Section 8.4, as you can see on the screen behind me, is all about solving word problems that involve using systems of equations. This tends to be a little more challenging simply because you're not given the equations. In most cases, you have to develop them yourselves from reading the problem and then go ahead and solve them using graphs, substitution, or elimination. Whatever appeals to you or whatever seems easiest of those three methods. In order to solve a word problem, remember, the first step is you always need to read and try to comprehend the word problem. Okay? So, step one, you got to comprehend it. You got to know what's going on. Step two, you need to set your variables. So in other words, you actually need to write down let x equal blah 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 and let y equal blah blah blah. And try to be as specific as you can when you're setting those variables. Okay? If you're trying to find a number of tickets purchased, say that. Let x equal the number of tickets purchased. If on the other hand you're trying to maybe find the price of a ticket, then you would say let x equal the price of the ticket. Okay? It's really important because it helps you to do the next step, step three, which is to develop a system of two equations. Okay? You can't really see that. There we go. Develop a system of two equations. Okay? Once you've got those, the rest is hopefully relatively easy. Solve the system. Okay? And this is where you decide, oh, this one looks like it would work best with substitution or elimination or graphing. Okay? So the first thing we're going to do is very quickly, we're just going to solve this particular system, and it's asking us to solve it three different ways. Okay? Now, I'm not going to solve it three different ways because that's going to take a lot of our time up. Okay? I'm going to assume that you're fairly comfortable with solving by substitution and solving graphically. We'll just go through the steps that you would go through to solve this graphically. So to solve it graphically, they've been very nice to us. They've given us both equations in slope-intercept format. So you simply need to know what is the slope. In this case, for the first one, it's 6. For the second one, it's -2. Remember, we can write those as fractions because they give us direction. Okay? And the y-intercept for the first one is 3. That means it crosses the y-axis at 0 and 3. For the second one, the y-intercept is -29. And again, that means it crosses the y-axis at -29. Okay? Now, since this one crosses the y-axis so far down, I would strongly suggest that maybe you do something like this. Okay? So, put your x-axis way up there. That gives you more room for your y-axis. And I would suggest you might want to go up by 3. So 3, 6, 9, -3, -6, -9, and so on. Your x-axis, not quite as important. We can go up by 1s. Okay? and then you simply plot your points. So for my first one, my y-intercept is at 3, or 0 and 3. So there's my y-intercept. My slope tells me to go up 6 and right 1. So I'm going to go up 6, so from 3 to 6 to 9. Okay, remember you're not counting 6 squares, you're counting from the number, which is 3, and you're going up 6, which brings you to 9. And across 1, remember the scales are different, so be careful. There are your 2 points. Okay, join them up, and we're good. Well, we may as well finish this up. Okay. So join your points, and there's your first line. For the second line, the y-intercept is at negative 29, so 12, 15, 18, 21, 24, 27, 30, so it would be right around here at negative 29. And our slope tells us we have to go down 2 and right 1. So if we're starting at negative 29 and we're going down 2, we're going to go down to negative 31, and then we're going to go right 1. Okay? So we end up roughly here. Okay? That gives us an intersection point here. Now, this is nowhere near an intersection of grid lines. Now, that could be because I did a crappy job on the graph, but we can estimate that it's at about negative 3.5 for our x, right? 1, 2, 3, and about a half. And going down, negative 12, 15, 18, 21, maybe about 23. So negative 23. Okay? And that's our solution. To solve by substitution, remember, you would simply isolate one of the variables. They're both isolated. We may as well do this. We'll do the substitution one. So both are isolated. So remember, the second step for substitution is you take the expression you have for y in the first one and you sub it in for y in the second equation. So instead of y equals negative 2x minus 29, we're going to write our value for y, 6x plus 3, equals negative 2x minus 29. And then, excuse me, we have to isolate the variable. That means we have to get all the x's to one side. So I'm going to add 2x to both sides to get all my x's over to the right. That's going to give me 8x plus 3 equals negative 29. Then I still have to isolate x. So I'm going to get rid of this 3 because it involves adding and subtracting. We have to do that first. That gives us 8x equals negative 32. Excuse me. 8x equals negative 32. Dividing through by 8 gives me x equals negative 4. Now, you'll recall, excuse me, I got a frog in my throat. You'll recall that we said it was at about negative 3.5, but you'll also recall I said, well, maybe it's just my crappy graphing. But we got fairly close. So we say we have a value for x of negative 4. So we found half of our solution. Now we sub that value back into either equation. I'm going to use the first one because it's a little simpler. So our y equals 6x plus 3 becomes y equals 6 times negative 4 plus 3 y equals negative 24 plus 3, y equals negative 21. Okay? Which is fairly close to what we had, right? Remember, we had our solution down here with both x and y coordinates negative. Remember, you can always verify simply by substituting your values for x and for y back into both equations to make sure that they work. Okay? We'll move on to the next question, which says, which method do you prefer for this system? Well, that's totally up to you. In the case of this one, if you like graphing, these are already isolated for y, so you can easily plug them into your graphing calculator. Also, if you like substitution, as we used, they're isolated for y, so you have one of your variables with a coefficient of 1 and it's isolated already, so that makes substitution pretty easy. But if you look at this, you'll see that we also have the same coefficient in front of our y's. Our equations are written so that everything lines up nicely, so you could very quickly use elimination. You could subtract y equals negative 2x minus 29 from y equals 6x plus 3. So in this case, they're all pretty easy, right? They're all pretty user-friendly. So it just boils down to what you prefer. It says, Matt claims that if a linear system includes a vertical or horizontal line, the best method for solving is usually by substitution. Do you agree with Matt? Why or why not? Remember, if you have a vertical line, it takes the form x equals n, where n is simply a number, right? The point where that vertical line crosses, so you have a vertical line, it's x equals n, and n is the x-intercept, okay? If you have a horizontal line, it's y equals n, where n is simply, here's our y, here's our x, where n is simply the y-intercept, okay? Now, what these result in, and I'm just going to substitute a number for n. This looks like it's probably at about negative 5. My y looks like it's probably at about negative 4. Now, if you look at that, if one of your lines is a vertical line, you already know what the value for x is. So you've already got half of your solution before you've even started. And that's why I would agree with Matt that the best method would be by substitution, because you already have half of your answer. It's just a matter of substituting that value for x if it's vertical, or that value for y if it's horizontal, into your other equation, solve for your other variable, and you're done. Okay? So yeah, I would say Matt is onto something. Now this is where we get into the most difficult part of solving word problems, and that is you will generally be given a description of a situation in words, which you then have to take and convert into a system of two equations. Okay? So what you have here is, and you can't see it because I don't have enough room on my screen, but you have 4 different scenarios, and for each scenario you're asked to match it to the appropriate system of equations. Okay? So these are vertical, so these 2 equations describe one of these scenarios, these 2 another one, and so on. So our first one says, Tyler wants to know how many days he will need to visit the ski hill for a season's pass to cost less than buying a pass for each visit. Now, you have to think about this a little bit, but basically, you have two variables here. One of them would be the total cost. So we could say let C equal the total cost. Okay, whether you pay for each run for an entire season, or whether you buy a season's pass at the very beginning and then it's free. Okay, every time you go, you don't have to pay. Another variable here that we need to consider, we'll call N, and that's the number of visits. Okay, now the numbers don't really matter, okay, but what we're after is a description of the situation. So an equation that would describe him buying a season's pass would simply have a total cost that he lays out. That total cost is not going to depend at all on the number of visits because it's a season's pass. Okay? So we have a system of equations here that very nicely describes it. So this would be the season's pass, where your total cost is just some initial outlay, okay, and then you don't have to pay again. If you look at the one below it, you'll see that that one has a total cost, and it does depend on how many visits you make, okay, which is what you would expect if you have to pay every time you visit. So this one is probably a system of equations describing situation A. Okay? For situation B, it says Elizabeth is comparing the cost of continuing to run an old furnace with the cost of buying and running a new furnace. So, again, our two variables would be the total cost and if you buy a new high efficiency furnace, or if you keep your old furnace, you're still being charged a certain amount every month for your gas, okay? Depending on how much gas you use. So we're going to have another variable, and again, we'll just call it N, number of months. Okay? Using these two things, you can then figure out which system of equations applies. So, in the first case, if you're running an old furnace, you don't have any kind of an initial outlay, right? You've already owned the furnace. You're just paying your monthly gas bill. But because it's not a high efficiency furnace, you're going to be using more gas. Okay? So, in the second situation, buying a high efficiency furnace, again, you're going to have an initial outlay. You've got to buy the thing. And then you're going to have a monthly charge for gas, but it's going to be lower than it would be if you kept your old beater of a furnace. Okay? If you take a look at this system of equations, you'll see that this has a total cost based on a certain charge per month, but you don't have any other costs. If you look at the second one, it has a total cost. It has a term that describes a certain payment times a certain number of months. Notice, though, that it's less than this one. That would be our high efficiency furnace, right? The reason you buy it is so that you can save money, excuse me, so that you can save money on your gas. And that's why you'll see there's a constant term with this one, and that's telling you basically you've spent $3,400 on your furnace, and then you're paying a lower monthly cost for that furnace. Okay? Now you could use these equations to figure out how many months would you have to operate your new high efficiency furnace in order to make up the cost of that initial outlay on your furnace. Okay? From the looks of things, it would be about 4.5 years. Okay? Which isn't bad because most furnaces last for 20 or 25 or 30 years. Okay, let's go to the next one. The next one is very simple. It says the sum and difference of two numbers is shown. What are the numbers? So we would say let x be the first number, let y be the second number, and then all we're dealing with is a sum and difference. And the only trick to this one is remembering what sum means and what difference means. Remember, you get a sum when you add, you get a difference when you subtract. And you're doing that to these two numbers, x and y. So we're looking for a system of equations that has x plus y, that's the sum of the two numbers, and x minus y, that would be the difference. And as you can see, we have that right here. Okay? And process of elimination means D must be this one. Okay? Now we get into the problem solving. And we'll try and do a couple of these. Okay, now this is kind of similar to what you may have done in Math 10-3 when we talked about earning an income. Okay, so it says, Ariel has been offered 2 jobs. One job pays $10 per hour plus a commission of 2% on all sales. The other job pays $12 an hour, so she gets more per hour, and a commission of 0.5% of all sales, so she makes less in commission. How much merchandise would she need to sell in each 8-hour shift for the 2 jobs to pay the same? Okay? So, as I mentioned in an earlier video, with word problems, usually at the end of the description, they'll give you some idea of what the variables are that you're looking for. Okay? So, we're looking for the 2 variables. Let P equal her paycheck, so how much she makes. And the other thing we don't know is how much merchandise would she need to sell. So we'll say let S equal her sales. So how much merchandise she had to sell. Okay? And then we can come up with a system of equations from this second sentence here that describes how much she would get paid on this plan. So our first equation would be her total paycheck equals, now it says it's an 8-hour shift, so her total paycheck would be $10 an hour times 8 hours plus her commission. She makes 2%. Remember from this chapter I referred to in 10-3, we always have to change percent to a regular old number, to a decimal, so that's why this 2 becomes 0.02. Remember, you just divide by 100 or move the decimal 2 places to the left. And we're going to multiply that by her total sales, okay? Because she gets 2% of everything she sells. Our second equation then becomes, and we're just going to simplify this, 10 times 8 would be $80 for an 8-hour shift. That would be her hourly paid. The second comes from the next sentence, where she gets $12 an hour, so 12 times 8, or 96, plus 0.5% percent of all sales. And as a decimal, again, remember you move the decimal 2 to the left, that becomes 0.005 times S. Okay? So this is the hardest part of solving a problem with a system of equations. It's coming up with those two equations that you'll need to use. Now that we have these two equations, we can decide how we want to solve them. Okay? Now, in this case, we might be best off solving by elimination, because as you can see, we already have our variable p with the same coefficient, right? There's a 1 in front of both of these. So that's what I'm going to do. I'm going to solve by elimination. Since the sign on p is the same, in each case they're both positive, we'll subtract. That gives us p minus p is 0. 80 minus 96 is negative 16. And 0.02 minus 0.005 is 0.015 S. Okay? What does that do for us? That eliminates one of our variables. That's why it's called elimination. By eliminating one of the variables, we can then isolate S. So we're going to get an S all alone. We'll add 16 to both sides. That gives us 16 equals 0.015 S. And then to get rid of this 0.015, we simply divide both sides by 0.015, 0.015. They cancel on this side, giving us S. On this side, give me a minute. That gives us $1,066.67 for our sales. So this is our S value, 1066.67. Okay. Take your value for S, sub it back into one or the other of your equations, it doesn't matter which, and that is how you get your value for P. So we're going to use this first equation, P equals 80 plus 0.02, and where we have S in this equation, we're going to sub our value for S, 1066.67. P equals 80 plus, and we'll figure what this is in a second. It is 21.33 for a paycheck of $101.33. 101.33. So what does that mean? That means that these two plans will pay exactly the same amount, $101.33, if you have sales of $1,066.67. Okay? So in other words, again, if we go back to the idea of these both being equations for a line, that's where the points cross. So if you were to plug both of these into your graphing calculator and find the point of intersection, it would be right here. Okay? So we've solved the system of equations. We've figured out how much she would have to sell. She would have to sell $1,066.67 for both jobs to pay $101.33. Does the conclusion agree with the original information? What are they asking you here? They're asking you to verify. Okay? So again, remember, you have to plug these two values into these two equations, and make sure the left side equals the right side. Okay, we'll move on because I would like to get at least one more problem done. So this one says, when 20 identical rectangular tables are placed end to end, their perimeter is 326 feet. When they are placed side by side, their perimeter is 136 feet. Okay? So basically what they're saying is, you have rectangular tables, and in the first case, you're placing them end to end, right? So you've got something that looks like this, okay? And dot, 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 from table number 1, 2, 3, all the way to table number 20. So you're going to get a long, skinny row of tables, okay? So that would be the diagram that represents the first scenario. The diagram that represents the second scenario would be to place the tables side by side. So the first one, second one, the third one, all the way to the 20th one. So. Now in this case, you have the length, the length, the length, the length, and so on, where the ends are the width, okay? With this one, you have the length, and then the width, the width, the width, and so on, like that, okay? So, what are your unknowns? Should be fairly obvious from the diagram. Our unknowns are the width of the table, and the length of the table. Okay? So, now you have to come up with two equations. Now, in the first case, it says the perimeter is 326 feet when you arrange them like this. Okay? Now remember, the perimeter is simply all the way around your object. So, for this one, so we'll call this number 1, we'll call this number 2. For number 1, our perimeter is equal to, how many lengths do we have across the top? Well, there's 20 tables, so we have 20 lengths. How many lengths across the bottom? Well, same 20 tables, same 20 lengths. So, we have 40 of those lengths. We have only 2 of the widths, right? So we have 20 lengths, another 20 lengths is 40. A width here and a width here gives us 2 widths. And our perimeter is 326 feet. So we can replace P with 326. How about equation number 2? Well, for equation number 2, our perimeter is different. It's only 136 feet, and it's made up of 20 widths, another 20 widths across the bottom, so 40 widths. I'm just lining these up. And then our lengths, we've got one here, we've got another one at this end, so we've only got 2 lengths, okay? So, there are a couple of different ways we can solve this problem. I would say probably it might be easiest to use, well, we could use elimination, okay? If we multiply the bottom here by 20, let's just get rid of this. If we multiply the bottom by 20, that will make our lengths the same. So our 326 equals 40L plus 2W. I'll just rewrite. This one, when we do the multiplication, we get 2720 equals 20 times 2 is 40L. 20 times 40 is 800W. We've made the coefficient of length the same. Since they're both positive, we know we have to subtract. And when we subtract, we get, Mr. Calculator, please. Negative 2394. 40 minus 40 is 0. 2 minus 800, whoops. 2 minus 800 is negative 798W. Last step, we want to isolate W, so we divide both sides by negative 798. And what that gives us is our value for W, which is 3. Okay? So, we're halfway there. We know that our value for W is 3. We've got about 5 minutes left, so we'll just finish this one up. Okay? So, now we have a value for W. We plug it into one of our original equations. Doesn't really matter which one. We may as well use this other equation so it doesn't feel lonely. So, plug our value for W in here. That gives us 326 equals 40L plus 2 times 3, our width. Just get rid of this so that it's not in the way. And simplify. 326 equals 40L plus 6. Isolate L, we'll take away 6 from both sides. 320 equals 40L. We'll divide through by 40. And what do we get? 40 divided by 40 gives us 1L. 320 divided by 40 gives us 8. And so our length is 8 and our width is 3. Okay, so what does that mean? That means each table has a width of 3 feet and a length of 8 feet. Okay, so they're 3 by 8 feet. Okay, let's just move on and make sure we've answered everything. So we've sketched our diagram, we've written our system of linear equations, and we've discovered that the dimensions are 3 by 8. Okay? That will have to do it for today. Have a lovely day. Please continue to show up for the help sessions. That really does help. We will be doing a review for this unit in preparation for your test. Have a great day. See ya.